Okay, the code is compiled right now, and it's showing the name of the machine. And here we are using Adafruit as a Adafruit motor shielder as a H bridge to run the stepper motors and the servo, because in the simulation we use another kind of motor driver. It's called AD 4888 something. Okay, but we didn't get it. But in our electromechanical kit we have Adafruit already, so it's also a H bridge, so we are using it. See, in this the first sequence is already started. It's about the drawing of the square, but we have a problem. Servo is working, but not 100% accurately. We are connected the servo from the servo pin above the Adafruit shield, and we don't know what's the problem behind it. Then in this we are using LCD as a HMI interface, and here we have left and right stepper motors, and we can see the sequence details there. The stepper motor running at what we are expecting, and we can debug the problem about the stepper. We can solve it out, and we used a breadboard for the connection, and in this case we didn't use any 12 volt supply, because we didn't apply any we don't want to apply any load here, because it's just a demonstration. For a better understanding, we add a clips here. See the HMI. It's showing the pen functions, means the servo's actions, but our servo is didn't react accurately. In this case, we can sort it out. We can go through the codes. Maybe some kind of misconnection is the reason behind that, but the servo getting the supply because it's work twice, but not continuously, so we can clear this thing. That won't be a problem, and we using a separate code for this, because simulation, it's we also mentioned that there are some difference. We use in simulation A4988 module as a motor driver, but in this case we already have a Adafruit shield. It's also a motor driver, and so what we used in simulation, we didn't get a Adafruit shield in this simulation. That's why we use this stepper motor driver in the simulation. It's a small change. Actually the sequences are same, the main codes are same, it didn't change, but only the base things like the initializing the Adafruit and initializing the motor driver is the only difference here. And we finally got the problem behind the servo problem. Actually we want to connect the Arduino from pin 9, but we use the servo pin 1. Well, I installed both libraries, Liquid Crystal I2C by Frank D. Bradenter, and the library for the Adafruit Motor Shield version 2.3 that we are using here. And the code is compiled right now, and we can upload the code. Once more, check the port is, yes, it's connected, and let's upload the code. Well, here it is, cable robot, pen up. Now at the beginning, 2 days back, I got an error in the servo motor. It's not working properly. It's because of the connection problem, because we connected using these servo pins, but now we are connecting using this 9 pin digital pin PWM, and now the motor is moving. You can see the movement in XY directions. See the pen up, servo is working properly. And see, move to the other position. Again pen up. We have 2 red flags, red tags here. In the latter video it didn't have a flag, we used just the clips only. Now we have it. Pen up. I think now the square sequence is going on. Again pen up. Diagonal. Now the diagonal is started. The second sequence is started. Move to the 100 position. Moving to the other position, 500 700. Now I think the second sequence, third sequence, the circle is happening. Well, it's demonstrating equally. I think we didn't use micro stepping in this. At the first of beginning, we have planned to use the micro stepping for better accuracy, but this is fine, it's working good. But we don't know if a proper wall mounting setup is happening. We get the proper clarity, like we need more accuracy. We can use it. It's just a single board changing, like it's from the single to